enjoyed our favorite festival Onam. Now let's get back to our regular online class wherein we are continuing the same chapter, acids, bases and salts. Today we are going to learn about very interesting topic, neutralization. What do you mean by neutralization? Any idea? No. We have learned acids, bases and their properties. The reaction between acids and bases is known as neutralization. Salt and water can be formed in this process. Some heat is always produced in this process, neutralization. I repeat, the reaction between acids and bases is known as neutralization. Salt and water can be formed in this process. The neutralization reaction can be represented as acid plus base, salt and water. When acid and base combine together, the product formed as salt and water. Some heat is produced during this process, always produced during this process. For example, hydrochloric acid is an acid. Sodium hydroxide is a base. Hydrochloric acid. Hydrochloric acid is an acid and sodium hydroxide is a base. When hydrochloric acid is treated with sodium hydroxide, then a neutralization reaction takes place to form sodium chloride and water. Sodium chloride and water. Sodium chloride is a common salt. I repeat, when hydrochloric acid is treated with sodium hydroxide, then a neutralization reaction takes place to form sodium chloride and water. Sodium chloride is a salt. The neutralization reaction can be represented as hydrochloric acid. Hydrochloric acid can be represented as HCl. Sodium hydroxide. Sodium hydroxide can be represented as NaOH. Yes, sodium chloride. Sodium chloride can be represented as NaC plus water. Water can be represented as H2O. NaCl is a common salt. In the neutralization reaction, the salt is formed when hydrochloric acid is treated with sodium hydroxide. Now, let's watch the video based on this topic.
Here, let us perform an activity to know about neutralization reaction. Click each tab to know more. Take a test tube Clean it using a clean dropper. Pour 10 drops of hydrochloric acid carefully in the test tube. Now, add 2 drops of phenolphthalein indicator solution. Observe the color changes. Now, add sodium hydroxide solution drop by drop to the test tube. Shake it well after adding each drop. Observe the change in the color of the solution. Keep adding the sodium hydroxide drop by drop until the color begins to turn pink. Once again, add drop by drop of hydrochloric acid to the solution mixture until the solution in the test tube becomes colorless. In this activity, we observe that there is no change in the color of hydrochloric acid while adding phenolphthalein solution. The color of the solution in the test tube becomes pink by adding a drop of sodium hydroxide solution. The pink color of the mixture solution becomes colorless by adding a few drops of hydrochloric acid. Finally, we learned that if we add excess base, that is sodium hydroxide, to acidic solution, that is hydrochloric acid, it converts to base. Similarly, we can change base into acid. We also learned that the effect of base is nullified by an acid. When acids and bases are mixed in definite proportions, they give a neutral solution. The reaction of an acid with a base produces salt and water.
Now let's see certain examples of neutralization in our day-to-day life. Indigestion. Our stomach produces hydrochloric acid which helps us to digest our food. The excess of acid in the stomach causes indigestion which produces pain and irritation. In order to cure indigestion and get rid of pain, we can take bases called antacids. Antacids are group of mild bases which have no toxic effect on the body. Being basic in nature, the antacids react with the excess of acid in the stomach and neutralize it. This gives relief to the person concerned. A common antacid used for curing indigestion is the milk of magnesia. Milk of magnesia contains a base called magnesium hydroxide. Magnesium hydroxide. Magnesium hydroxide neutralizes the excess of acid in the stomach and cures indigestion. The second example is anbine. diarambic, baking soda or calamine lotion which contains zinc carbonate. Next example is soil treatment. Excessive use of chemical fertilizers makes the soil acidic. Plants do not grow well when the soil is too acidic or too basic. If the soil is too acidic, it is treated with bases like quicklime or slate lime. If the soil is too basic, organic matter such as compost added to it. Organic matter releases the excess amount of acid, neutralizes the basic nature of the soil. The next example is factory waste. The factory waste contain acids. If they are allowed to flow into the water bodies, it will kill fish and other organisms. The factory wastes are neutralized by adding basic substances.
Dear children, take your science textbook and see page number 56. Now we will discuss the exercises. We have done some questions from this exercise in the notebook. You don't need to do it again. But the question which you have not attempted should be completed in your back side of the notebook. Let's start. Exercises. First, state differences between acids and bases. Second, ammonia is found in many household products such as window cleaners. It turns red litmus blue. What is its nature? Answer. The nature of the ammonia is basic. Question number 3. Name the source from which litmus solution is obtained. What is the use of this solution? Question number 4. Is the distilled water acidic, basic, neutral? How would you verify it? Question number 5. Describe the process of neutralization with the help of an example. Question number 6. Mark T if the statement is true and F if it is false. Question number 1. Nitric acid turn red litmus blue. Answer. False. Second, sodium hydroxide turns blue litmus red. Answer false. Question number 3. Sodium hydroxide and hydrochloric acid neutralize each other and form salt and water. True. 4. Indicator is a substance which shows different colors in acidic and basic solutions. True. 5. Tooth decay is caused by the presence of a base. False. Question number 7. Dorji has a few bottles of soft drink in his restaurant. But unfortunately, these are not labeled. He has to serve the drinks on the demand of customers. One customer wants acidic drink. Another wants basic, and third one wants neutral drink. How will Dorji decide which drink is to be served to whom? Answer. Dorji can use litmus paper to check if the drink is acidic, basic, or neutral, and can serve the correct drink as per the demand of the customers. Question number 8. Explain why an antacid tablet is taken when you suffer from acidity. B. Calamine solution is applied on the skin when an ant bites. C. Factory waste is neutralized before disposing it into the water bodies. Question number 9. 3 liquids are given to you. One is hydrochloric acid. Another is sodium hydroxide. And third is a sugar solution. How will you identify them? You have only turmeric indicator. Answer. If we put drops of a base on turmeric, then the red color will be obtained. If we mix acid with turmeric, then there will not be any change in the color. Here, on mixing turmeric indicator with hydrochloric acid, there will not be a change in the color. But when we will mix sodium hydroxide, we will get a red color. The sugar solution is neutral in nature, So, mixing it with turmeric indicator will not cause any change in color. Question number 10. Blue litmus paper is dipped in a solution. It remains blue. What is the nature of the solution? Explain. Answer. We know acid turns blue litmus to red, and neutral solution has no effect on the litmus paper. As there is no change in color, so the solution can be either basic or neutral. Question number 11. Consider the following statements. A. Both acids and bases change color of all indicators. B. If an indicator gives a color change with an acid, it does not give a change with a base. C. If an indicator changes color with a base, it does not change color with an acid. D. Change of color in an acid and a base depends on the type of the indicator. Which of these statements are correct? First, all four. Second, A and B, D. Third, B, C and D. 4. Only D. The answer is option 4. Only D. Change of color in an acid and a base depends on the type of the indicator. Dear children, take your science textbook and write. Answer the following. First, describe the process of neutralization with the help of an example. Answer. The reaction between an acid and a base is known as neutralization. Salt and water are the products of this reaction along with the evolution of heat. For example, when hydrochloric acid is added to sodium hydroxide solution, it forms sodium chloride and water. Hydrochloric acid plus sodium hydroxide gives sodium chloride plus water. HCl plus NaOH gives NaCl plus H2O. Question number 2. Explain why A. An antacid tablet is taken when you suffer from acidity. B. Calamine solution is applied on the skin when an ant bites. C. Factory waste is neutralized before disposing it into the water bodies. Answer A. Acidity or indigestion in the stomach is caused due to excessive production of hydrochloric acid. Antacid tablet contains milk of magnesia hydroxide, and it is taken to neutralize the effect of the acid. B. Ants injects formic acid into the skin when they bite. Calamine lotion contains zinc carbonate, which neutralizes the effect of the acid. Therefore, it is applied to the skin to reduce the pain and swelling. C. Factory waste usually contains acids which can harm aquatic animals and plants if allowed to flow into water bodies. Therefore, it has to be neutralized before disposing it into the water bodies. Question number 3. What are neutral solutions? Answer. The solutions which do not change the color of either red or blue litmus are known as neutral solutions. These substances are neither acidic nor basic. Example: sugar solution, salt solution.
Now let's summarize what you have learned. Acids are sour in taste, bases are bitter in taste and soapy on touching. Acids turn blue litmus to red. Bases turn red litmus to blue. Special type of substances which are used to identify whether a substance is acidic or basic is known as indicators. An acid and a base neutralize each other and form a salt. A salt may be acidic, basic or neutral in nature. From this, we are finishing our 5th lesson. I hope you are clear with all the topics that we have covered today. Please read the textbook 2 or 3 times and also go through the exercises and question answers. Complete your notebook. Okay children, take care. I will meet you in your next class.